Hi, hello, who are you? My name is Anna Tinpencil. Welcome back to my channel. We are going through as many LeetCode problems as we physically possibly can in a year, and you guys are here for the journey. We are on question 81, search and rotated sorted array. Now, I did this one back in August, so I'm going to show you guys the solution and kind of break it down in terms of what I did, but my submission wasn't terrible. If I can pull it up here. I got 46% in memory in terms of users in Python. But I got 77 in runtime, which I felt pretty good about. And you guys are more than welcome to read this question on your own time. But basically, what I chose to do was flesh out an algorithm that used a modified binary search to take into account the presence of duplicates in a rotated sorted array. So I was trying to efficiently handle the search for the target values and return true if it was found and false otherwise. So that is the basis for this solution. So let's jump into this here. Right in the beginning here, we have two pointers to find the length of the array, left and right, which represent the range that we're currently searching within. And the main part of the code that really is like the meat and potatoes of this is the while loop that continues as long as left is less than or equal to right, and that just performs a binary search in that rotated array to find the target. Now, inside of this loop, we can calculate the middle index or mid using the average of left and right to avoid integer overflow. Like, that's huge. So for this, if num's mid is equal to the target, we return true because we found the target. Simple. And if there are duplicate elements in the beginning, then of this array, then we increment the left pointer to skip those duplicates. And this step basically ensures that this particular algorithm works correctly when there are duplicates in the array. So we then check to see if the left part of the array from left to mid is sorted, or then the right part, which would go from mid to right, is sorted. If the left is sorted, then we check if the target falls within that range, right? If it does, then we go ahead and update the right pointer to mid -1, which basically effectively eliminates the right part for consideration. If the target is not within the left part, though, then we just take that updated left pointer to mid +1 to then search the right part of the array. And if the right part is sorted, we perform kind of that same similar check, updating the left to the right pointer accordingly. So that will just continue until the target is found or it exhausts the search range. And if the loop continues without finding the target, then we return false, which down here on the bottom is what we did. So that's explaining this particular code. Like I said, I do like this solution. I probably could have made it a little less wordy, and I think that probably would have helped in both aspects, maybe not runtime, but definitely memory. But overall, a solution that I'm pretty happy with and that I have in my GitHub repo, which is linked down in the video description down below, so you guys can fork it and clone it, make it better, make it worse, have some fun, learn something new, and I will see you in the next video.